Myself, P Patil, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. These are the learning outcomes. So, my dear friends, at the end of this particular session, you are able to solve the problems on center of gravity and moment of inertia. Calculate the moment of inertia about x-axis for this section shown in a figure. So please observe one semicircle and the tapered shape one figure is there. Let's we bifurcate the figure into two parts. This is my figure number 2. This is my figure number 3. If I bifurcate the figures in three parts, so I am considering the centroids. This is G2, somewhat here G1, somewhat here G3 is there. I am considering the reference axes. So first one reference axis I am considering from left hand side. This is 1. Second one reference axis I am considering from the top. So this is my second reference axis. 2 is there. First of all, we'll calculate the area, right? So area of first one figure, this is A1. Area of second figure, A2. Area of third figure, this is nothing but your A3 is there. How to calculate it? Area of first figure, that is the rectangle is there. So B into D is there. Area of second figure, that is nothing but semicircle is there. So pi r square by 2 is there. Area of third figure, that is nothing but the triangle is there. So how to calculate it? 1/2 into base into height. 230 into 150. This is the area you will get regarding your rectangle. 34500 mm square. Find out the area of semicircle. This is pi into r is 75 square divided by 2. So you will get 8835.72 mm square. 1/2 base is 100, height is 230. So we will get the area of third figure, that is rectangle, is 11500 mm square. Now the next part is there. You may identify the centroidal distances. So you may observe this is your y1 from a reference axis. This is your y2, and the last one, this is nothing but your y3 is there. Okay, this is very important. You may calculate the centroidal distances. Centroidal distances. So how to calculate the centroidal distances? Y1. So this distance I required. This is 75. Y1 is equal to, how to calculate it? 75 plus 75 plus, now I require half of this, 230 by 2. 230 by 2. You will get, this is 190 mm. How to calculate y2? This is nothing but the small distance. So all of you know this is nothing but 4r upon 3 pi. 4r upon 3 pi. So I need this particular distance. So 75 minus 4r upon 3 pi. 75 this total minus 4r upon 3 pi up to the G2. We need this particular height. This is nothing but your y2. 75 minus 4r upon 3 pi. So r is 75. 75 minus 4 into 75 divided by 3 pi. You will get 43.17 mm. And the last one, this is your y3 is there. How to calculate y3? So this is the base, this is the toe. From toe, this is 2/3 of the span. Span is 230. So the 230 already they are given. Right. So now 2/3 of the span. So up to here you will get the distance plus 75 is that. So 75 plus 2/3 of the span. Span is 230. So you will get the value 228.33 mm. Next part is that is the y bar. Y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by total area, that is a1 a2 a3. A1 is, all of you know, 34500. A2 is 88.935.72 and A3 is 11500 mm square. If I put the value of A1, A2, A3, simultaneously if I put the value of Y1, Y2, Y3, you will get the Y bar from top. The Y bar from top is 174.37 mm. I request all of you, you may put the values in this particular formula, because we know the value of all the areas, we know the value of all the centroidal distances. Put the value and you may identify. This A is nothing but addition of A1, A2 and A3. So you'll get 174.37 mm is there. Let's see, observe. Now Y bar is over. You know the value of Y1. Y1 is how much it is? 190. Y bar is, you may observe here, is 174. So somewhat here your x-axis is there. So this is nothing but your Y bar. This is nothing but your Y bar. Now I need the distances, that is h1, h2 and h3. This is very important. How to calculate h1, h2 and h3? So let's you observe. H1 is nothing but this particular distance. H2 is nothing but, you may observe, from here to these x-axis. So this is your H2 is there, and from here to here, this is nothing but your H3 is there. Okay, this x-axis to G1 vertical distance, this x-axis to G2 this vertical distance, this is your H2, and this x-axis to G3 this vertical distance, this is nothing but your H3 is there. How to calculate it? H1 is equal to, let's you observe H1. So this total distance, you may observe, this is nothing but your Y1. Y1 minus Y bar, you will get H1. Y1 minus Y bar. So Y1 is 190 minus your Y bar is 174.37. You will get the value of H1. H2, how to calculate it? H2 is nothing but this distance now. Let's say observe. So this is total Y bar. Y bar minus Y2, you will get H2. Total is Y bar minus this small distance. This is nothing but your Y2. So Y bar minus Y2, you will get H2. Y bar is 174.37 minus your Y2. Y2 is 43.17. You will get H2. Simultaneously H3. Now this distance. So total is Y3. Y3 minus Y bar. Y3 minus Y bar. Let's say observe. Total distance Y3 minus Y bar. You will get H3. So Y3 minus Y bar. Y3 is how much it is? Already we have calculated 228.33 minus 174.37. So we'll get the value of H1, you will get the value of H2, you will get the value of H3. So let's see, observe here, the value of H1 is 15.63 mm, H2 is 131.2 mm, H3 is 53.96 mm. Why I need all these particular values? So to identify the moment of inertia, we require all these particular values. Moment of inertia first for rectangle about x-axis, moment of inertia of semicircle about x-axis, triangle about x-axis. So the formula is like this: Ixx 1, this is for a rectangle; Ixx 2, this is for semicircle; Ixx 3, this is for triangle. So what is your formula? Your formula is BD cube by 12 plus A1 H1 square. Moment of inertia of semicircle, how to calculate it? About x-axis, 0.11 r raised to 4 plus A2 H2 square. Moment of inertia of triangle, this is about the centroidal axis, BD cube by 36 plus A3 H3 square. All of you know the area, all of you know the base. So if I observe the figure, so regarding this particular rectangle, this is the base, this is the depth. So base you may consider here, the base is 150, so 150 you may consider, and the depth is you may consider 230. Okay, so here you may consider 150 into 230 cube divided by 12 plus area of figure number 1, already we have calculated here. The area of figure number 1 is 34500 into H1, already we have calculated 15.63 square. This is first one. Second one you may consider 0.11 r raised to power 4. So for semicircle, so the radius is 75. So you may consider here 0.11 into 75 power 4 plus area of second figure, already we have calculated, this is 8835.72 into H2 square, 131.2 square is there. This is regarding second. So let's you observe, this is regarding your second. And third one, BD cube by 36, B is 100, depth is 230 cube divided by 36 into area of the figure, that is you may observe here the area already we have considered 11500 is there. So you may consider here plus 11500 into 53.96 square. So the total Ixx is equal to Ixx1 plus Ixx2 plus Ixx3 is there. Let's do the calculation and try to identify it. So after calculation you will get the values of Ixx1 is 1.60 into 10 power 8 plus 1.55 into 10 power 8 plus 0.67 into 10 power 8. So you'll get at last, that is 3.83 into 10 power 8 mm raised to 4. This is the moment of inertia about x-axis. Prepare the video or report. These are the references. Thank you.